define for me what we are doing when we are using an inverse function. Think back to last lesson, the basics of an inverse function, what we actually do. What's it used for? So what do we use a function for? What do we substitute? What? Into x. So we have a function, we put x into the function. What comes out? Y, a number, the value of that function. Okay, so what's the inverse function for?
We try to find x.
And you start with?
Y.
So start with y, try to find x. However, if we then call that an inverse function, what do we do with the y into the function to give x when we actually write the inverse function? What's the final step? We
write y as an x.
So we swap x and y. Alright? So when you write your inverse function, you rearrange to make x equals something in terms of y. But to write the actual function, you swap x and y around. Alright? I want you to think about that. So here's on the screen are a function and its inverse. So the red one is my function 2x plus 1. The inverse is x minus 1 over 2. Now if you think about it, the red line is an x value. So in this case, this is what a function is. I should be able to pick an x value, so that value is 1. And the red line tells me what the y value is. So it's 3, yeah? So 1 goes into the function, 3 comes out. So what should the inverse function tell me for that point? So if 1 goes into the function and 3 comes out, what should be true for the inverse function, Tim? For the inverse function, no. What goes into the inverse function? So 3 goes in, and what should come out? 1. Does it? 3 goes into the inverse function, 1 comes out.
Is this a sketch? Is it like
No, this is exact because it's on the computer. Okay. Now here's the thing. So, to make you aware, if 1 goes into the function, up, 3 comes out. So that's the f of x. This one doesn't work very well, does it? F of x. But if I use f to the minus 1 of x, right, I swap it around. So 3 goes in, okay, 1 comes out for f minus 1 of x, the inverse. So basically all I'm doing is swapping the x and the y coordinates. Now you have done transformations. Which transformation is it when all I do is swap the x and the y coordinates? Yana? It's not a rotation, no. Janice? A reflection, but more specifically, because you can't just say reflection. Ishan, you with me, Lucrezia? This is the important bit.
Reflection by x equals y?
Yeah, that's it. It's a reflection in the y equals x line. So, if I were to put that in there, alright, y equals x, you can see that quite clearly that the inverse and its function are reflections. So just to show you maybe a more difficult one, right? I'll get rid of those two. We'll put one of the ones that you might have been struggling to see. I'll put a reciprocal function in, which is just anything of the form 1 over x. Okay? What is the inverse function of 1 over x? Well, let's have a look. If I put, what would the function be? You can't just say x, it has to be y equals x over 1, that's y equals x. Yeah, no?
X over no.
Yeah. Look at it. What do you notice about the graph of 1 over x?
Symmetric.
It's symmetrical about y equals x. Therefore, the inverse of 1 over x is 1 over x. It's one of these self-inverse functions. Okay? So that's interesting to see. What if I have 1 over, and I put brackets in, x minus 2, for instance. Let's do that one. All right, it's a bit different. So this time, this is not a self-inverse function. So what do you think the inverse function of 1 over x minus 2 is? Have a go, sketch it if you like. Not sketch it, write it down, work it out. 1 over x minus 2, what do you think the inverse function is? So we think it's, and I think you're right, it will be 1, not 1 plus 2 over x, no.
1 over x plus 2.
1 over x plus 2 is the inverse function. Now what we're expecting to see is a reflection in y equals x. Is that what we have?
Yeah.
We do. Okay, oh, sorry. So, that's it then. So then this is what we're trying to show. So if you are, for instance, in an exam, it says, oh, sketch the inverse of this function. Alright? But it doesn't tell you what the function is, it just gives you the graph. You know, the one thing you know is that the graph of an inverse function is the reflection in y equals x. Okay? Okay with that?
Yeah.
Right, go on.
Usually in past papers they ask to write what's
The asymptotes.
What's that?
We don't know what asymptotes are. No? Okay. Alright. We'll go on to asymptotes. Are we happy with this inverse function thing? Just the fact that it's a reflection in y equals x. That's summing it up. Any more questions on that before we move it? Yeah?
How precise would it be, like how precise would we have to be in the exam, then like to draw the reflection?
Well, certain points have to be right, for instance. So what I would do if I were you is draw y equals x in and make it clear that certain points are... So this is, if I know, for instance, that this is 3, 1, this has to be 1, 3. Certain points probably have to be. So, for instance, anything that was a y-intercept has to become a x-intercept, definitely. They're the things you have to show, have to get right. The other ones, roughly the right shape and things, but things like maximum points, minimum points and so like that will be important. Right, before we go on to the asymptote thing, because that's useful for these graphs, I want to have a look at one other thing about functions. Alright, could you please work out the inverse function of x squared plus 2. So the inverse function of x squared plus 2 for me. And then graph it on your calculator, both of them together. Alright? That's what I want you to do. So x squared plus 2. Right, so we've got x squared plus 2 on the screen. Yours look like that, roughly? Different scales might look a bit different. Right. What's the inverse of x squared plus 2? What did you work it out to be? Y equals, Alexander?
Square root of x minus 2.
So the square root of x minus 2. Right. What do you notice? Anyone?
It's no half rotation, one side only.
Okay, so it's not rotation, let's get that right. It's a reflection still. Right.
Yes,
Have we got the first thing? Is it a reflection in y equals x? Well, sort of. It's half a reflection. It's only half of it. Any idea why? Ricky?
Because you got the square root negative number.
Okay, so here's the thing, isn't it? It's an important point, actually. X squared, when you put a value of x into x squared, any x number you like, the answer will always be what? Positive. Always be positive. Alright? So, put minus 3 in, I get 9. So, an inverse function needs to take that 9 and give me how many solutions?
2.
So if I put 9 into the inverse function, what needs to come out the other end?
Positive number.
3 and minus 3. So when we do, we've done this in calculations, when we do the square root of something, we must always consider plus or minus. Okay? Your calculator can't do that. Your calculator can only plot functions. And this is the thing. This is an important thing to remember. Probably only worth 1, maybe 2 marks in the exam, but it's the difference between A stars and A's, that kind of thing. A function, okay, a function takes one input and gives one output. Alright? So one input can only give one output for a function. I can have 2 inputs give the same output, is fine. But I can't have one input give 2 outputs. If it does, it's not a function. Do you understand that? So it's kind of the one-to-one, many-to-one, one-to-many situation, if I say that. So one input gives one output. So that's one-to-one. If I say two inputs can give the same output, that's fine. So with x squared, minus 2 and 2 give me 4. So that's many to 1. That's fine for a function. But you cannot have, alright, 1 to many. You can't have one input to many. So in this case, the calculator and my graph has only drawn half of the inverse, because what we say is anything with x squared officially does not have an inverse function. It doesn't exist. There is no inverse function to x squared. Alright? Now what your calculator does to get over that situation is only draw half of it. Alright? Have you got that? Now here's the thing. Here's how you decide whether a function is a function or not. And it's called the vertical line test. Alright? So if I were to draw the other half, so I'm just going to put negative the square root of x minus 2. Alright? So that's what it would look like if it was a true reflection. Now, what I mean by the one-to-many thing is this. If I just draw a vertical line, so I'm going to put an x equals 5 in. If I draw a vertical line, if I can draw a vertical line and it crosses the function, what I think is a function, more than once, it's not a function. Understand? Alright? So that's what's called the vertical line test. So if in an exam paper, like maybe a paper 6 for instance, it says, is this a function or not, give a reason, you can give a reason like it fails the vertical line test. Now is anyone, before you write your notes, I'll let you have a moment in a second, is there anyone that thinks, but I could use that with the initial function to decide if it's going to have an inverse or not. So is there any test we could do with the original function to test whether it's got an inverse or not? Are they?
No.
No.
Just make it negative.
Make what negative?
The initial function.
What I'm looking for is there a test? So for instance, if I take a vertical line and it crosses the function twice, all right, then it's not a function. But, so that means what I could do, if I said to you, does this function have an inverse function? What you would do at the moment is work out what you think the inverse function is, graph it, and then decide if it passed the vertical line test. But is there any way you could test the original function without having to work out the inverse function to see whether it had an inverse or not?
Because it's a diagonal reflection, you could just do a horizontal line test.
Exactly. All right. Do you all get that? If I do a horizontal line test, okay, on the original function, if that crosses twice, that means there will be no inverse, because the inverse will then be crossed twice by a vertical line. Make sense? All right. So there's like a quick way of going. Actually, no, there isn't. So, well, I'll let you make your notes on that, and then I've got another one to look at. Right. So make your notes on that.
If horizontal test,
So a horizontal test on the original function, if it fails that, it will not have an inverse function, because the inverse function would fail a vertical test.
But it will be still a function, right?
Yeah, the original function is a function unless it fails. If it fails a vertical line test, it's not a function. But you know if it fails a horizontal line, the inverse will not be a function. All right? Just to finish off the last minute, guys. On the screen is a cubic. Will that cubic have an inverse function or not?
yes.
Yeah.
But it passes.
Go on, Ella, what are you going to say?
Horizontal.
So a horizontal line test would cross how many times?
It could cross once as well.
But is there any point where it crosses 3 times?
Yeah.
Yes.
So what do we think? Is it going to have an inverse or not?
No.
I put it in the calculator and I had an inverse.
So if we go equate, well, we'd have to work it out. We'll do it next time. But I want you to have a think. Does the cubic have an inverse or not? Okay.